Hello everyone, welcome back to this channel. In the previous video, we started looking at the linked list data structure. In this video, we are going to be looking at the code implementation of a singly linked list. And also, I have included unit tests. This is a series, so this is the 13th video in this series. I'm going to put the link of the playlist in this video description so that you can check out all the videos. That being said, let us hop into the code. Alright, so here is the code. I have implemented this data structure in Golang, but you can implement it in any language that you use because the concept is the same. Here we have the code. And here we have the tests. Okay, so we have the node struct. A struct is like a class in a language like JavaScript or Java. Okay, so the node struct contains two fields, which are a data and the next pointer. Okay, in this case, the data is an integer. Okay, while the next is a node pointer. Okay, so we also have the singly linked list struct. Okay, and this has three fields, which are the size of the linked list, okay, a pointer to the head node, which is the first node in the linked list, and a pointer to the last node, okay, also called the tail. All right. The first operation here is the clear operation. And what this method does is to clear the entire linked list. It does this in linear time, okay, by deallocating all the elements or all the nodes in the linked list. So how can this be achieved? So let's look at the steps followed. So the first step is to check if the list is empty. If the linked list is empty, then we're going to return true since there is nothing to deallocate. The list is already empty. Otherwise, we are going to traverse the linked list. So think of traversal as looping through the linked list. Okay, we're going to start from the head. As you can see that trav currently stores the address of the head node. Okay, then why trav is not nil, meaning that why the list is not empty. First, we're going to extract the next node because we are going to need it later. Okay, then we're going to set trav.next to nil. Okay, so this is how we deallocate the next node. Then now we're going to set trav, okay, to the next pointer. So this the trav pointer now stores the address of the next node. Okay, so this is how we are going to traverse the linked list and deallocate the elements. However, trav started from head, right? And in the first traversal, what we are going to deallocate is head.next. I hope that is clear. Okay, so up to this point, the head is not nil, because we started from trav.next. We started deallocating from trav.next. Okay, so in order to clear the entire linked list, okay, or to deallocate the head, we're going to set list.head to nil. Okay, all right, then to be sure also we are going to set list.tail to nil. Okay, then we're going to set the trav pointer to nil. Okay, this is very important, especially in languages like C or C++, where you manage your memory manually, okay, in order to avoid memory leaks. Then we're going to set list.size to 0 since our linked list is now empty. Then we return true, meaning that the clearance is successful. Okay, so this is how you clear the entire linked list. The next operation here is the index valid method, this is not doing much. This is just checking if an index is valid or not. Okay, so as you can see, the method is accepting the index parameter. Okay, then if the index is less than 0, okay, or the index is greater than the list size minus 1, because we are starting from 0, we are starting the indexing from 0. So if the index is greater than list size minus 1, definitely that index is not valid, then we return false. Otherwise, the index is valid, so we return true. So that is what this that is the function of this method. The next method here is the list size method. Okay, and what this does is to return the size of the linked list. Okay, so it's a very simple method. Next method here is the empty method. It returns a boolean. Okay, if the list is empty, meaning that the size is 0, it returns true. And if the list is not empty, meaning that the list size is not 0, then it returns false. The next method here is the add method. So what this does is to add a new element to the end of a linked list, and it does this in constant time, and that is because we have a reference to the tail. I explained this in the last video. So let's look at the steps we are going to follow to achieve this operation. So the first thing to do is to check if the list is empty. Remember that we declared this function here, okay, so we can reuse it here. Okay, so we're going to check if the list is empty. So if the linked list is empty, we're going to create a new node. Okay, as you can see the value is the value parsed, and the next pointer currently points to nil because it is a new node, and also the linked list is empty. Okay, so the head is going to store the address of this new node. Okay, then we're also going to set the list tail to the address of the head. Okay, then we're going to increase the list size by 1, and we're going to return true. So this is the case if the list is empty. So let's look at the other case. The other case is when the list is not empty, right? So what we are going to do is to create a new node. Okay, then we're going to set the next pointer to nil. Okay, the next step is that we would set the current tail next pointer, okay, to the address of the newly created node. Okay, so then we're going to set the list tail pointer now to the newly created node. Then we're going to increase the size by 1 and return true, meaning that the addition is successful. So this is how you add to the end of a linked list. So this can be called push in some cases. Some you can see it called append in some cases. Okay, so the major concept is that you add to the end of the linked list. The next method we are going to be looking at is the remove last method, and the function of this method is to remove the last node in the linked list, and this is achieved in linear time. The first thing to do is to check if the list is empty. If the list is empty, then we're going to log an error in the terminal or in the console. Next, we are going to create 2 pointers that point to the head. Okay, so whiteraf.next is not nil. Okay, so this loop is going to stop before we get to the tail node. Okay, so we're going to set new tail variable pointer to trav, okay, and we're going to set trav to trav.next. So like this, we will have a reference at the end of the day. We will have a reference to the tail, and we will have a reference to the node before the tail. Okay, so the new tail will point to the tail before the node before the tail, and trav will point to the tail node. Okay, so the next thing to do is to set the new tail pointer dot next to nil, okay, because now it is our new tail, okay, and the next pointer on the tail always points to nil. Okay, then we're going to make the list tail point to the new tail. We're going to extract the data in trav. Okay, we're going to set trav to nil. Okay, so this is kind of deallocating trav. We'll reduce the list size by 1. Okay, now if after this operation over here the list size is 0, then we are going to set the list head and the list tail to nil, meaning that the list is now empty. Then we return the data. Okay, so this is going to be the data that we removed. Okay, so this is how you remove the last element in the linked list. The next method that we will be looking at is the remove head method, and what this does is to remove the head of the linked list, and this happens in a constant time because we have a reference to the head. So the first thing to do is to make sure that the list is not empty. So if the list is empty, we're going to log an error to the console that the list is empty. Otherwise, we're going to create a pointer to the current head. Okay, so the reason this is named previous head is that at the end of the day, this node will be removed. Then we're going to extract the data from the current head node. Okay, so the first case here is if we have a single node. Okay, so if we have a single node, we're going to set the list head, the list tail both to nil, right? Then we're going to set the size to 0, and then we return the element or the value stored in the head node. So this is the case if we only have a single node in the linked list. So if we don't have a single node, so meaning that we have more than one node in the linked list, we are going to set the list head now to the previous head next node. Okay, so that is what this basically do. So this is already storing the address of the next node. Okay, so we store that address in this head pointer. All right, then we're going to set the previous head to nil. So this is to help us deallocate this particular where this node is stored. So we're going to deallocate it from there. Okay, then we're going to reduce the size by 1, and we're going to return data. Okay, so the data is the data stored in the removed heads node. The next method that we will be looking at is the add to head method. So what this basically does is to add a new head to the front of the linked list, and this happens in a constant time. So let's look at how this can be achieved. The first thing to do is to check if the list is empty. So we do that by checking if the head is nil. So if the head is nil, it means that the linked list is empty. So then we are going to create a new node. Okay, the value will be the value that was passed. Okay, and the next pointer will point to nil. Okay, Then now we're going to store the address of this newly created node, okay, which is stored here. We're going to set it to the head. So now the head currently points to the newly created node, okay. Then also we're going to set the tail to the address of the newly created node. We're going to set the size to 1 because this is the first node in the linked list. Then we're going to return the value. So the value was the value that was passed here, okay. All right, so this is the case if the list is empty. If the list is not empty, then we're going to have to follow this step. All right, so if the list is not empty, we are going to create a new node, as you can see here. Now take note that the value of this node is the value parsed, but the next pointer now points to the head, the current head, okay. So we are going to set the list head pointer to the new node. We are going to increase the size by 1. Then we are going to return the value that is stored in the head. So this is how you add to the head of the linked list. The next method that we are going to be looking at is the get method, and what this does is to return the data stored at a particular position or at a particular index in the linked list, and this happens in a linear time. So the first thing is to check if the list is empty. If the list is empty, then we're going to log an error in the console that the list is empty, okay. Then the next thing is to check if the index is valid. Remember that we declared this this method earlier, so we're going to check if the index is valid. If the index is not valid, then we are going to log this error to the console. Otherwise, we are going to check if the index is 0. So if the index is 0, then we just return the data stored at the head node. Then we're going to check if the index is the index of the last node, okay. So if the index is the index of the last node, we are going to return the data stored at the tail, okay. So instead of we having to traverse the linked list, we can just return the data stored at the head or at the tail based on the index, okay. So if the index passed is not the index of the head or of the tail, then we have to traverse the linked list, and that is what we are going to do here, okay. So trav currently points to the head node, okay. So yi is equal to 0, I less than index, and I plus plus. We're going to set trav to trav dot next, okay. So this is how we traverse the linked list. Then we're going to return trav's data. So the data is the value stored at trav, okay. So at this point, trav will be the node that we are seeking, okay. So this is how you get the element stored at a particular position in the linked list. The next method that we will look at is the remove method, and what this basically does is to remove a node at a particular index, and that happens in a linear time. So the first thing we're going to do is to check if the list is empty. If the list is empty, then we are going to log an error in the console that the list is empty, okay. Then we're going to check if the index is valid. So if the index is not valid, we're going to log an error that the index is invalid. So this kind of doing a bound check here, okay. Then we're going to check if the index is 0. So if the index is 0, we are going to reuse this method called remove head. Also, if the index is the index of the last node, then we are going to reuse this method called remove last. We already declared this function, right, or this method. Okay, so if the case is not any of these two, okay, then we're going to create a trav pointer that points to the head, and also a previous node that points to the head. The reason for having this these two pointers will be made known soon. Okay, so what we're going to do now is to traverse the linked list. Okay, so at the end of the day, the previous node pointer is going to point to the node before the node that we want to remove. Then the trav pointer is going to point to the node that we want to remove. Okay, so we have a pointer to the node before the node we want to remove, and we have a pointer to the node that we want to remove. Okay, so now we are going to extract the data stored at trav. Okay, then we're going to set trav's previous node next pointer, okay, to trav next pointer. Okay, so this is where the deletion, where deletion actually happens. Okay, because like this we are skipping the trav node here. Okay, so we are setting the previous node next pointer to the trav next pointer. Okay, so now we are going to set trav to nil. Okay, we're going to deallocate trav, then we're going to reduce the list size by 1, then we're going to return the data that we just removed. Okay, so this is how you remove a particular element in the linked list. Okay, the next method that we have here is the index of method. Okay, so basically, well, this accepts a value, then we're going to check the index where that value is stored in the linked list. Okay, and that happens in a linear time. So we're going to check if the list is empty. Okay, if the list is empty, then the operation is invalid, right? So we're going to log an error to the console. Otherwise, we're going to create the trav pointer that points to the head. We're going to create this variable index that is initially at 0. Okay, so why trav is not nil, okay, we are going to check if trav data is equal to the value that was passed. So if they are equal, then we're going to return the index of the current value of the index. Okay, otherwise, if we are not able to find the data that we are looking for, then we're going to set trav to trav's next pointer. Okay, so this is just to kind of move to the next node in the linked list. Then we're going to increment index by 1. Okay, then if all this after all this traversal we are unable to find the index of this value, then we're going to return -1, meaning that the value is not found in the linked list. So this is how you find the index of an element of a value in the linked list. The next method that we're going to be looking at is the contains method, and what this does is to check if a value exists in the node or not. So it's a boolean. If it exists, it returns true, and if it doesn't exist, it returns false. So we're going to check if the list is empty. If the list is empty, then we just return false, okay, since the list is empty. Otherwise, we're going to create a trav pointer that points to the head of the linked list, and why trav is not equal to nil, okay, we're going to check if trav's data is equal to value. So if they are equal, we've actually found that value, then we return true. Otherwise, we continue to traverse, and we do that by setting trav to the trav's next pointer. Okay, so if after this part we were unable to find the data, then we return false. Okay, meaning that we could not find that value in the linked list. Okay, so the last method here is the print list. So basically what this does is just to loop through or traverse the linked list, as you can see here, and then it prints the data stored at each node in the linked list. So that's the function of the print list method. Okay, so those are the operations that are performed on a linked list. If you check out this tab, okay, so I've written a unit test for this method, as you can see over here. Okay, and if we go ahead and try to run the test, okay, let's check that out. Just gonna say, so this is Golang, so I'm gonna say go text -v. Let's see. Okay, so you can see that all the tests are passing now. Okay, so please, you can check this out also. Thanks everyone, thanks for staying to the end of this video. Please don't forget to subscribe to get notified when a new video is uploaded. So please ensure you click on the subscribe button. Okay, thank you very much, and I will see you in the next video. See you soon. Bye.